Alright, welcome. In this video we're going to be practicing our 3x3 systems of linear equations, and we're going to be working on Algebra 2 Homework 2.2. So the first one is kind of one that's set up nicely for substitution. It's going to start you off with x equals 4, x plus y equals -6, and what else? 4x minus 3y plus 2z equals 26. 4x minus 3y plus 2z, 26. All right. So, okay, we've already got x. That's good news. So then we're just going to use that x to find y in the second equation. So I'm just going to substitute there. So 4 plus y equals -6. So I'm going to subtract 4 from both sides to solve for y. And I'll see that, okay, y is going to need to equal -10. And then I will substitute on x with 4 and y with -10. And then I'll have, okay, 4 times x minus 3 times y plus 2z equals 26. All right, so I've got 16 plus 30 plus 2z equals 26. And 46 plus 2z equals 26. So I'll subtract 46 from both sides. Okay, 26 minus 46 would be -20. I'll divide both sides by 2, and I'll get z equals -10. So my solution is x equals 4, y equals -10, and z equals -10. All right, the second one is also one that's, I mean, we could definitely use elimination on it. And if you want to just go elimination, you know, you can do that, right? It says use substitution, but, you know, I'm not going to not give you credit for the homework if you don't use substitution on the second problem. Okay, if you're going to use substitution, though, you're probably going to want to solve for that z, because it's pretty well set up for it. So I'm going to go over here and I'm going to say, okay, I'm going to add z to both sides. I'm going to get x plus y equals z. And then I'll use that to substitute on the other two equations right there and there. So I'll have x plus y plus z is equal to x plus y. So I'll just say that's equal to 24. And 5x plus 3y plus z, which is x plus y, that's going to equal 56. So, and this is going to be my two equations and two variables that I need to, you know, carry forward. So once I combine these terms, I'm going to have, all right, 2x plus 2y equals 24 from the first equation. And then the second equation, I'll have 5x plus another x is a total of 6 x's and 4 y's. And that's going to equal 56. I think the most sensible thing to do would be to eliminate on y here, but you can, I mean, you could do substitution again if you really felt like it. I'm going to eliminate on y, so I'm going to multiply equation 1 right here. I'm going to multiply it by -2, so I can get -4y and +4y. So I'll have -4x, I'm going to multiply everything by -2, minus 4y equals -48. And then I'll have 6x plus 4y equals 56. I'm not going to change that one. Then I'm going to add these together, and I'm going to get -4x plus 6x is going to be 2x, no y's, equals 56 minus 48, that's going to be 8. So I've got x equals 4. Okay. Then I'm going to go back to one of my original equations in the 2 by 2, maybe 2x plus 2y equals 24. So, all right, then I guess we'll go down here. 2x plus 2 equals 24. Did not leave enough room for this. So it's going to be 8 plus 2y equals 24. I'll scroll down for a second. I'm going to subtract 8 from both sides, and I'll get 2y equals 16. And I'll divide in half, and I'll get y equals 8. Okay, so I've got x equals 4, y equals 8. And I've got a formula for z, because I did substitution. I got x plus y equals z. So x plus y equals z. So I've got z equaling 12. And so my solution is going to be the point where x is equal to 4, y is equal to 8, and z is equal to 12. All right, now let's solve using elimination, okay? And this one is really well set up for elimination. You could eliminate on x, you could eliminate on y, or you could eliminate on z. Me personally, I'm going to eliminate on y because I've got negative 2y and then two other positive 2y's. So it should be really easy to eliminate y. I'm going to actually just kind of state that off to the side. Okay, plan is to eliminate y. And so how I'm going to do that, if I label this equation 1, equation 2, and equation 3, I'm going to do equation 1 plus equation 2 to get rid of the y's. Okay, and so if I do equation 1 plus equation 2, I'll have x plus 3x, that's going to equal 4x. Negative 2y plus 2y, that's going to be 0. And then plus z and minus z, that's also going to be 0. This is very convenient for me, you know. I'm going to say negative 11 plus 7 is negative 4. Okay, that's good news. I'll deal with that in a second because I don't want to lose sight of what I'm doing here, right? Get too excited so okay, I can see what x is going to be. Okay, what we need to do is we're going to need to add equation 1 to equation 3 to eliminate y in the second equation. And I'll have x plus negative x is no x's. Negative 2y plus 2y is no y's. So z plus 4z is 5 total z's. That's equaling negative 11 plus negative 9 is negative 20. Okay, so this really turned out like, this is a 2x2 system, but it's not one that's difficult to solve. I'm just going to divide by 4 and divide by 5. So I've got x equals negative 1. And I've got z equals negative 4. Yeah, when I divide negative 20 by 5, I'll get negative 4. And so I just need to pick one of the original equations. It doesn't matter which one, just pick one of the ones that's written in black. And just plug in and find y. Okay, so maybe I'll do x minus 2y plus z equals negative 11. Okay. I'll say then I'll have x minus 2y plus 1z equals negative 11. Okay, so I'm going to, combine like terms. Negative 1 plus negative 4, that's going to be negative 5. I'm going to add 5 to both sides. So negative 11 plus 5 is going to be negative 6. Then I'll divide both sides by negative 2, and I'll get y equals 3. Now I've got them all. Okay, x is negative 1, y is 3, and z is negative 4. All right, this fourth one, we want to use elimination on it. And, I could see us going again on any of the 3 variables. This one looks like it's gonna work out pretty nicely. Maybe this time I'll eliminate on x, okay, because I've got that x and the negative x, and then I've got a 2x, so all I really need to do is multiply the third equation by 2 once. So yeah, I'm going to do that. So my plan here is going to be eliminate x. Okay. And so in doing that, I'm going to label my equations, equation 1, equation 2, and equation 3. And I'm going to add equation 1 plus equation 3 to take advantage of that negative x. Okay, and then I'm going to also do equation 2 plus 2 times equation 3. Now, if you're ready to just kind of like do that addition in your head, you can be my guest. But what I'm going to do is I'm going to go off to the side and I'm going to write down 2 times equation 3. I think I can do equation 1 plus equation 3, right? Because x plus negative x is 0. 4y plus 2y is 6y. Negative 6z minus 4z is negative 10z. And then I'll add these two things together, negative 1 and positive 5, and I'll get 4. Okay, that's fine. I think we can do that without rewriting the 2 equations. But equation 2 plus 2 of equation 3, that's something we might need to be careful with. So equation 2 is 2x minus y plus 2z equals 7. No, negative 7. And that was equation 2. And then 2 of equation 3 is going to be negative 2x, just double everything, plus 4y minus 8z. I don't know where my page is going. That's going to be equal to 10. Let's get that back. Yeah. All right, then I'm going to add these things together, and I should have an equation in y and z, just like this other one over there. Okay, no x's, 3 y's, negative 6 z's equals 3. Okay, so I've got 3y minus 6z equals 3. Okay, from here, I mean, you could multiply this new equation over here. You can't even see my cursor. I could multiply this one by what? 3 and the bottom one by negative 5 to eliminate z. But that's not going to be the way to go. Look, 3 and 6, right? We're going to eliminate y from here. So if I label this one equation 4 and equation 5, okay, I'm going to need equation 4 minus 2 equation 5s. Okay. So I'm going to go, maybe I'll make this a little smaller. Yeah, that'll be all right. Okay, and then, I'm not sure, I don't see that random blue writing in the middle of the screen on mine, but I don't know what that is. Okay, we're going to say, all right, 6y minus 10z equals 4, and then I'm going to multiply everything in this bottom equation, equation 5, by negative 2. So I'll have negative 6y plus 12z equals negative 6. Multiply everything by negative 2. Yes, okay, and then I'm going to add these all together, and I'll have 0 y's plus 2 z's equaling negative 2. And now I've got 1, right? I've got z equals negative 1, because 2 times negative 1 is negative 2. Then I'll go back to one of the equations in my 2 by 2, maybe 3y minus 6z equals 3. So 3y minus 6 times z equals 3. So 3y plus 6 is equal to 3. I'm going to subtract 6 from both sides. And then, let's see, would that cover it up? Okay, yeah, that's strange. Interesting. But anyway, y is also going to equal negative 1. And then, I'll go back to one of my original equations, maybe the equation 1. X plus 4y minus 6z equals negative 1. Okay, so x minus 4 plus 6 equals negative 1. So that's in total x plus 2 equals negative 1. I could subtract 2 from both sides and get x equals negative 3. And then, I didn't leave a whole lot of room for it, but I can write my solution is going to be x equals negative 3, y equals negative 1, z equals negative 1. All right, now it's just, here's a system, solve it however you're going to. You can use substitution or elimination. I'm thinking, okay, this one isn't like super clear one way or the other. Okay, if you wanted to do elimination, you would probably solve for y or solve for z in the first or second equation. If you wanted to do elimination, I would not recommend eliminating on x, right? Because that 2, 7, and 4, that's going to be troublesome. I think what I would do is either eliminate on y or z, but I don't really want to multiply, say the second equation by 6. That's kind of a lot. The numbers are going to get big. So I think I'm going to eliminate y. But, you can go whatever way you want, right? So I'm going to label them equation 1, equation 2, and equation 3. I'm going to say, all right, I'm going to need to do negative 3 equation 1s plus 1 of equation 2. And I might just write that in because negative 6x, I'm going to multiply everything in the first equation by negative 3. So negative 6x, negative 3y, positive 9z equals positive 6. And then I'm just going to copy in 7x plus 3y, no, minus z equals 11. And then I'm going to add them together. And I'll have negative 6x plus 7x, that's 1x, that's kind of promising, plus 8z equals 17. Oh, feels to me like if these are going to be integers, a good hypothesis is going to be x equals 1 and z equals 2, right? But it could be z equals 1 and x equals 9. We don't know yet. Okay, we're going to then also eliminate y using the first and third equation. So I'm going to say 2 of equation 1 plus 1 of equation 3 to get that 2y and negative 2y. So I'll have 2 of equation 1 is 4x plus 2y minus 6z equals negative 4. And then plus equation 3 is just going to be, okay, wait, 2 equation 1, yeah, I'm eliminating y, okay, yeah. Plus equation 3, so 4x minus 2y plus 6z equals 5. Ah, yes, okay, I see where we're going here. I was wondering if this was going to happen ever. And then I'm going to add these two together, and I'm going to say 4x plus 4x. Oh, no, wait, let me make sure I didn't copy this wrong. Oh, I did copy this wrong. Okay, this is supposed to be a negative 4x. And so the only time this would pop up is right here. Yeah, I was going to say, I thought that, you know, in this lesson we're dealing with one unique solution and no solution, and I was kind of waiting for no solution to happen. Next time we'll deal with some infinitely many solutions. But yeah, so when I add these all together, I get 0x, 0y's, 0z's equaling 1. That's bad news. Okay, I get 0 equals 1. I'm going to say, no solution. And that's all we're going to say for that. All right, now this next one, maybe because I haven't given substitution as fair of a shake as I probably should have in my class, I'll do this one with substitution. But if you're, you know, a big-time eliminator, you continue being a big-time eliminator, I think, is going to be a thing to do. I might solve for z in the second equation. Yeah, or it doesn't really matter. I'll solve for z in the first equation. Either way, I'm going to substitute on z. Okay, so I'm going to solve for this z right here. So I'm going to subtract an x and add a 4y to both sides. So z equals negative x plus 4y. Yep, negative x plus 4y plus 5. Yeah, because I got to subtract an x and add a 4y to both sides of that equation. All right, and then I'm going to use that here and there. So I'll have 4x plus 2y plus z, which is a negative x plus 4y 5. That's going to equal 2. And then negative 4x plus 1y minus 3z's, that's going to equal negative 8. I'm going to need to distribute that negative 3 across everything, and then I'll have negative 4x plus 1y plus 3x minus 12y minus 15 equals negative 8. Okay, just distribute in that negative 3. Okay, now I will combine like terms on kind of, you know, now I'm not really looking at this one anymore because I was just cleaning up that equation to get to where I could combine like terms. Now I'm going to say, okay, 4x plus negative x is just 3x in that first equation there. 2y plus 4y is going to be 6y. And then I had that plus 5 equals 2. Okay, I'm going to want to subtract 5 from both sides to get it looking like usual, so that'll be equaling -3. And then over here on the right side, I'm just going to clear out some stuff. So -4x plus 3x is -x. Y minus 12y is -11y. And then I have a minus 15, but I'm going to add that to both sides, right? And I'm going to get 7. Okay. But now I should be done with all this scratch work on the left, so I'm going to clear it out. And hope I didn't make any errors in there. Okay, now I've got it down to a 2x2 system. You know me, I'm going to use elimination on this, right? You could solve for x and eliminate on x. Again, that would be if you're like a die-hard substitution loyalist, right? You're going to do that. And it'll work out just the same. It's just there's some that don't really work out well for substitution with the fractions. Okay, and if the numbers are getting too bad, then you might need to just switch over to elimination. Okay. But anyway, at this point, if I've got, this is going to be equation 4, and this is going to be equation 5, I'm going to need to add equation 4 to 3 copies of equation 5 to eliminate x. So I'll have 3x plus 6y equals -3, and then I'll multiply equation 5 by 3, so, oh no, that's not good. -3x minus 33y equals 21. Yeah, I just tripled everything. And then I will divide by, or no, not divide. I'm going to add down. So 6 minus 33 is, whoa, hold on. I've made it. Okay, no, I haven't. And this is actually probably good. I'm glad I put this on the homework. Good reminder that just because you're not going to get an integer as your answer doesn't necessarily going to mean you're wrong. Now, with linear systems of equations, you've seen this. It can go. It's a lot of algebra, and so we try to as often as possible make the answers nice. But this is still going to have a nice answer, and it's not going to be just integers, right? So I'm going to resume what I was doing before I kind of spooked myself, and I'm going to say, all right. 3x minus 3x, that's 0. 6y minus 33y is -27y. And 21 minus 3 is 18. So then I'll get y is equal to 18 over -27, which is -2/3. Okay, and -2/3 is not that bad of a number, right? We can work with it. It's actually a really nice rational number. It's the next best thing to a whole number. Okay, now having that, I'm going to go back to, I think probably, not loving that idea, -x plus 11y. Is there anything that I can multiply y by that will, yes, the 6y, here it is. Okay, so I'm going to use 3x plus 6y equals -3 to work better with that fraction. So I'm going to use equation 4. So it would be 3x plus 6 times y. Well, y is going to be a fraction, so I might write 6 as a fraction also. And 6 times y, and that's going to equal -3. So I've got 3x plus -12 over 3 is -4. So 3x minus 4 equals -3. I will make this a little smaller, I think. Make sure it's still on screen. Add 4 to both sides. Divide both sides by 3, and I get x equals 1/3. Okay, well, make sure against my technology that I got the right number. Yeah, it's 1/3. And then I'll use I've got a formula for z, so I'm going to, because I did substitution, so I'm going to use that. So I'll say z is going to be equal to -x, so that's -1/3, plus 4y, so that would be -8/3, 4 of -2/3, yeah, so plus a negative of 8/3. I'm just trying to, okay, that works. -8/3 plus 5. Okay, z is going to be equal to, well, -1/3 minus 8/3 is going to be -9/3, which is -3 plus 5 is going to be 2. And so my solution is 1/3 and -2/3 and 2. Which, yes, is what I got when I solved the system using technology. Okay, that one was a little tricky. All right, number 7, I did not have the energy to copy that all down, so I just snipped it out. Wholesale store advertises that for $20 you can buy 1 pound each of peas and almonds. Okay, I'm going to start designating some variables here. I think I'm going to let X be peanuts. It's going to be peanuts cost per pound, right? Okay, then Y will be cost of cashews, and then Z will be cost of almonds. So if you buy 1 pound of each, it's $20. Okay, that's going to be one equation. So 1 of X plus 1 pound of Y plus 1 pound of Z, that's going to equal $20. Cashews cost, whoops, bad grammar there, as much as peanuts and almonds combined. So that means Y equals X plus Z, right? If you combine the cost of peanuts and almonds, that's X plus Z, you're going to get the cost of cashews, that's Y. Okay, you purchased 2 pounds of peanuts, 1 pound of cashews, and 3 pounds of almonds, and that costs $36, and we want the price per pound of each type, right? So we want X, Y, and Z. Okay, this is set up perfectly for substitution, right? I've got a formula for Y here, and so I'm going to use that to substitute here and there. And then this will become a 2-variable, 2-equation system, and then I'll just go from there, like we've been doing. So Y equals X plus Z, so this is going to become X plus Z plus Z, because it's X plus Y plus Z equals 20. And then over here, 2X plus Y is X plus Z, plus 3 Z's, that's equal to 36. Right, so when I kind of clean up that first equation, I'm going to have X plus X and Z plus Z. That will be 2X plus 2Z equals 20. And then if I add 2X plus X in the second equation, I'll have 3X. Z plus 3Z would be 4Z's. And that would be 36. Okay, now I'm ready to do substitution or elimination. You know, you can do whatever you want. You could say X plus Z equals 10 if you wanted to divide that whole equation in half, if you thought that was going to be easy. That would be if you wanted to use substitution the rest of the way through. Personally, I'm going to use elimination because I'm going to multiply this whole first equation by -2. So I'll have negative 4X, negative 4Z, negative 40. Negative 4X, negative 4Z, negative 40. Just multiply everything by -2. And trouble keeping this on the screen. And then I'm going to add together negative 4X plus 3X is negative 1X. And then negative 40 plus 36, well, that's going to be negative 4. Okay, so that means that X equals 4. Okay, that makes sense. $4 per pound, that seems like a potentially reasonable amount of money for, you know, cost of peanuts. And it's not negative. That's the big thing, right? If we got 0 or negative, that would be a bad sign. That would probably be a sign we made an error. So, okay, let's just go ahead and pick one to go with. I might go with this one here. You know, 2X plus 2Z equals 20. So 2X plus 2Z, that's going to equal 20. So 8 plus 2Z equals 20. And I'm going to subtract 8 from both sides, so I'll get 2Z equals 12. Z equals 6. Okay, and then we've got this original equation we substituted on, y equals x plus z, so I think I'm going to just say y equals x plus z, which we had determined was 6. And so that'll be y equals 10. let's just check our answer for reasonableness real quick because these are good numbers. 2x's would be $8. Y would be $10. So I'm at $18 plus 3 6's is 18 more dollars. That's $36. When I add them up, do I get $20? Yes. And is y equal to x plus z? Yes, that was how I found y. Okay, so yes, this combination fits all three conditions. Okay, and so I've got a solution to the system. And so I would say peanuts are x is $4 per pound. Cashews is y, so cashews costs $10 per pound. And almonds, well, they're costing $6 per pound. Okay, the reason why I wrote it out like that is that if you look at what the question asked for, it asked for the price per pound of each type of nut. It did not ask for the values of X, Y, and Z. And, you know, in my class, like, I'm not going to penalize you for saying, hey, X equals 4, Y equals 10, Z equals 6. I am going to point out that the best response is one that directly answers the question and gives the price per pound for each type of nut. Okay, but that's enough. Let's move on. All right, this next one I'm not going to copy. I'm just going to copy in the equations. Okay, you got a total of 30 coins, and there are nickels, dimes, and quarters. Okay, I'm going to use the more obvious letters. N, number of nickels. What's going on here? Okay, D is going to be the number of dimes. And Q will be the number of quarters. So when they say that there's a total of, what would they say, 30 coins, I know that the total number of N plus D plus Q needs to equal 30. 30 coins. Total value of the coins is $3. Well, if I think to stay out of the realm of decimals, you could say 0.05 N plus 0.1 D plus 0.25 Q equals 3. I'm going to personally do it in terms of cents, right? 5 cents per nickel plus 10 cents per dime and 25 cents per quarter is going to equal 300 cents is $3. Okay, and there are twice as many nickels as there are dimes. Okay, this is the type of equation that you can, when you translate from English to algebra, you can do it wrong very easily. Okay, you can go very literally, which I'm going to recommend you do, but you should also check for reasonableness after you write it down. Okay, there are twice as many nickels. Oh yeah, this one you can't really translate, okay. But nickels is the one that there's twice as many of, right? So there needs to be more nickels than dimes. So this is going to be nickel equals 2 times dime, right? If nickel equals 2 times dime, then nickel's the bigger one. Okay, is your friend correct? Oh, okay, well then maybe this one's gonna come back no solution, because I'm kind of disappointing, only one come back no solution on this whole homework. So maybe the friend's incorrect, we'll see. All right, so we're just going to use substitution. 2 times D here and there. And so I'll have 2D plus another D plus Q equals 30. So it's going to be a total of 3D plus Q equals 30. And then when I substitute 2D and for N in the second equation, I'm going to have 5 times 2D is 10D, and another 10D, that's going to be 20 total D, plus 25Q, that's going to equal 300. And, well, looks possible. I don't know, but maybe it won't work when we go back to the other one. Let's see. I probably should use substitution again, right? I don't really want to multiply something 3 by 20 and 20 by 3. And I don't really want to multiply the top equation by 25 either. That's a place where I know that arithmetic errors can occur. So what I'm going to do is I'm going to just substitute on Q, I guess. I'm going to say when I subtract 3d from both sides, I'll have q equals 30 minus 3d. This looks like 30 minus 30. Let's see if I can, accentuate that letter. And then I will substitute on that. Oh, it's still going to have to multiply 25 by 30. There's really no way around it. And then maybe if you heard me say in class that substitution and elimination are actually the exact same thing, you might see it a little bit in my work here. That, I realized that if I scaled up the first equation by 25 to do elimination, I was going to have to multiply 30 by 25. And I know that's 750, but I know that's also a place where errors occur. But when I substitute, I'm still going to be doing 20d plus 25q, which is going to involve a multiplication of 25 times 30. So that's enough to say about that. 20d plus 25 times 30 minus 3d, that's going to equal 300. All right, then we're going to distribute the 25, 20d. 25 times 30 is 750. Minus 75d, that's equal to 300. Okay, now I'm going to subtract 750. And I'll have negative 450 there. And 20 minus 75 is negative 55. I'm missing something here. Thought maybe I was wrong. No. 55 doesn't divide 450, does it? I don't think it does. No, it does not. And so I guess you would say that because D is not a whole number, it's like 8.181818, something like that. Yeah. The D is not a whole number, and so the friend must not be correct. Yeah, I'd say it's not possible because we can't have, partial amount of dimes. Okay, so the friend's not correct. Okay, so this wasn't exactly no solution, but it was one where we had to think about it and be like, no, that's not possible. All right. Last one, number 9. Use a system of 3 linear equations and 3 variables to determine the price of each item of furniture. Okay, this was like, where is the information in here? You just gotta look closely. Okay, you've got sofa, love seat, chair are your items, and so we want the price of each. So I'm going to define my variables. X is going to be the price of sofa. Y is going to be price of one chair. That's tricky. And the Z is going to be the price of one love seat, which is like a couch but with only 2 seats instead of 3. And so the different prices, $1,300, $1,400, $1,600, that's going to give us our 3 equations. So I'm going to go over here and I'm going to say $1,300 is what you pay for one sofa and one love seat. So that'd be X plus Z. A $1,400 is a sofa and 2 chairs. It's going to be X plus 2Y. And then $1,600 is one of each. I wouldn't really recommend. You can substitute or you can eliminate, do whatever you want. But if you're going to, actually, I'm going to eliminate. Okay, this one looks a little weird. You can substitute on X. If that's the first thing you would think to do, be my guess. I'm going to do elimination just because I prefer it, and also this one's going to be a little weird when I eliminate. But I'm going to do, I think I'm going to do, if I label these equation 1, equation 2, and equation 3, I'm going to do equation 2 minus equation 1. And then I'll also do equation 3 minus equation 1. That's what I should have been doing from the first place. I see that now. Okay. And, you know, and so equation 2 minus equation 1 is going to be 1400 minus 1300 is 100 equals x minus x and y minus 2z, or 2y minus z. Okay, so I did incur kind of like more variables than I expected to. I didn't, you know, I kind of started with 2 variables in each equation. Now I still have 2 variables, but I'll have the same 2 variables once I do this elimination. And I actually think that equation 3 minus equation 1, 1600 minus 1300 is 300. Yeah, it's just going to tell me something directly. X minus x, z minus z. Well, that's just going to be y. So that's nice. And I've got 300 equals y. Now, go back into find z over here in the equation 2 minus equation 1 equation. So I'd say 100 equals 2y minus z. And so I'd get 100 is 600 minus z. Okay, and so I would subtract 600 from both sides. I get negative 500 is negative z. So z is feeling like 500. And then I need x, so maybe I'll do 1300 is x plus z. Yeah, that's going to be pretty easy. 1300 equals x plus 300. That's telling me x needs to equal $1,000. Okay, so price of sofa is going to be $1,000. The price of chair is going to be $300. It's kind of a lot. And the price of love seat is going to be $500. Okay, and that's it. And I think, yep, that's all for this homework. So that's going to be all for this video. Hope it was helpful. If you still need more practice, I have plenty of extra practice opportunities for substitution and elimination. So, you know, just stay at it, keep working these, and they do get smoother with time. So thanks for watching.